Okay. So yesterday I covered uh, big data fundamental and SDFS commands, SDFS Java API, SDFS REST API, okay, and MapReduce. So this is MapReduce is an analytics tool. Okay, so we covered MapReduce as analytics tool, and SDFS is the storage for Hadoop. Okay. So next is Hive. So Hive is again analytics tool. Okay, and Hive is originally developed by the Facebook. Okay, so Hive is completely a SQL tool, SQL data warehouse tool. Okay, so we will be learning all the SQL concepts as well as the Hive concepts. Okay, those are not in SQL, so some additional concepts. Okay, I prepared one document. Okay, or we can go first the installation. Okay, yesterday I found the issue in my Hadoop one. What was the issue in the installation of Hadoop? Okay, so first I show that, and then we will go for the Hive concept. Okay, so I have already connected my EC2 machine. Okay, so what was the issue in my yesterday in Hadoop, right? So actually in the bash RC, I was not giving a correct path. So here is the bash RC. So in the bash RC, the export path I did, right, for Hadoop. So here was the T was missing. Okay. So my actual path has the T, right? Software, this T was there, but I was not giving this T. Okay. That is the reason it was not able to recognize SDFS. Okay. So just make sure whenever you are getting the command not found something, so just make sure in your bash RC, the path is correct or not. Okay. If any mistake of this path will be, then you will not be able to access your Hadoop. You will not be access anything, whatever you are setting as your export path. Okay. So that is the issue. Okay. So how to install Hive? Okay. So next thing is Hive has the prerequisite Hadoop. Okay. So first of all, Hadoop services should be running. I already started my Hadoop. Okay. So if I check my JPS, here I can find resource manager, data node, name node, secondary name node, and node manager. All 5 services are keeping running. Okay. So next thing I have to start the Hive installation. Okay. So for Hive installation, so how I will start the Hive? So first of all, when I come to the right the installation for the Hive, so I need download the tar of the Hive. So I will go to the release, okay, and here I will find Hive 3.1.3. Okay, so this Hive 3.1.3, I will download it. I will be copying the link. I will go to my software here, wget, the same way like we did yesterday, Hadoop. Okay. So I will extract this. Okay. Now my Hive is extracted. I will rename this Apache Hive bin. I will make it this. Okay. And remove the tar file. So I have removed the tar file. Okay. So now my Hive is here. Okay. So now I have to set bash RC. I will go to the bash RC nano bashrc. You have to follow exactly the same steps given in this website document. Okay, so you have to follow the same. Okay, so once I have downloaded, I have extracted and everything I've done so far. Okay, so next is nano bash RC. So I'm setting this home path, but here is a mistake. So we have to correct it. So here is, first of all, this space should not be there. Here it should be starting with slash, and my user is Ubuntu / softwares. So I should not do any mistake. Apache Hive 3.1.3. The version is this one, and this is good. So we can copy this. We'll paste it. Okay. I will come out, Control X, Shift by Enter, source -rc. Okay. So I can see my, but I have to do many more things. I just started Hive. It will not be. So once I do this, I have to create okay, in the Hive env.sh, I have to set the Hadoop home path. Okay, so whatever Hadoop I installed, I will be setting the Hadoop path. Okay, I will be setting in. Software. On so Hive env.sh.template. So Hive env.sh template, I will rename first because it is a template file. Hive env.sh template. I will make it Hive env.sh. Okay, now I will edit this file. In this file, I will add my Hadoop path. Okay, here I can add it. But this path, I have to add it again. So my path is home, Ubuntu softwares. Softwares, Hadoop 3.3.5. Yesterday we did. This path. Okay, so this is a change we have to do. So we have to create these directories. Temporary directory we have to create. So one temporary directory we have to create. In the Hadoop, we have to create temp directory. Okay, this is already there. Okay, so we have to give the permission. So this is a Hadoop command. And second directory, I have to create a warehouse directory. It is an internal directory for Hadoop. Hive. It is internal warehouse directory where the internal table will be stored. Give the permission to the temp directory, this user warehouse directory. Once this done, I have to initialize the schema. I told yesterday that Derby is a database. Okay, so I have to change to Hive default XML template to the Hive site.xml. So in the conf folder, I will make it like now you will see Hive site.xml is there. So this is a Hive site.xml. Okay, so now next thing is I will initialize my Derby database. It's a metastore database. Okay, I will talk about what is a metastore DB, which is storing the information about the table, right? Whether it's a managed table, external table, table name, column names, column data types. So all those informations are stored. I'm initializing this Derby. So here is giving me this 3215 line number. I have this some special character.
Hello.
Yes, yes.
Someone in the lobby. Uh,
Control Shift hyphen. Go to the line number 3215. Okay. So this is a special character I have to remove. Okay. So this special character is a issue. Okay. So just we have to remove this special character. Control X, Shift Y, Enter. Okay. Now again I have to do init schema. Yeah. Now it's initializing. Yeah. So this step is done. So once it is done, so we are not getting this Java error. If you are getting this incompatibility of Java error, so you have to copy this 27 version jar from the Hadoop library to copy to Hive library. Okay, but if this issue comes, if this issue doesn't come, so we don't need to fix this issue. Okay, the next thing is I have to start the Hive. So I don't need to go to the bin. I can directly start Hive anywhere. Okay. So, but still one error will come more. Okay. So one error is, this is the last final error is coming, the Java IO temp.dir. So what is this error is? This error is in your hive site.xml, wherever this Java IO temp.dir is there, you have to remove those lines. Okay. So because basically it is not getting initialized. So I'm copying this and find in nano I. Okay. Go to the control W. Okay, so what I want to search, I want to search this string. So I found it, here it is. So I have to remove this properties. So remove very carefully because I have to start and end property, both I need to delete. So total 4 places we will find it. You have to delete. Okay, this is in the description. Even if you don't want to delete it, is fine. That's why. Enter. Yeah. So now your hive is ready to do work. Okay. So first I will do here show databases. So I can run the SQL command here, show databases. So right now only one default database will come, that is given by the hive. Slow. I will show in the my Ubuntu. This is just I shown for the installation. Maybe the RAM, right? Because I'm using a less RAM in my EC2 machine, so that could be a reason like it takes one. Should not take this much of time. Okay, so I start on the once your installation will be done, right? So you will see the Hive shell. Okay. Okay. When you start Hive, okay, let me start first the theory part. Okay. Okay. So we are going to start the Hive. So Hive is Apache's tool. Okay, it's a part of Hadoop ecosystem component, and Hive is a SQL data warehouse tool. And if we compare the Hive, we can compare with the other SQL DBs or Redshift in AWS and the SQL data warehouse tool in Azure. So we can compare with those tools. Okay. So hive is having the schema flexibilities, tables options, like we can create tables, partitions, bucketing. So these are the all options, right, we can do. And uh, hive is providing the JDBC, ODBC connectivity, and hive can connect from the other different or like operating system I can connect, right? Like I can connect with the Tableau with hive. So those are the options are there in the hive. So in Hive architecture, if I look at the Hive architecture, these are the main component of Hive. The one is Metastore DB. The Metastore DB is a separate DB, which is storing the schema, location, and the type of the table, and it is storing the table names, column types. So all those information, metadata about the data, about the Hive tables information is stored in the Metastore DB. The default database is supported in Hive is Derby, but we can configure our own separate DB. We can configure like MySQL, Oracle. We can configure in hivesite.xml. There we can define the configuration. Okay. The driver is another component in the Hive architecture. So driver is like it's a controller, and we can say which is like when the query you are submitting any query, so driver comes in play, and then it will be basically execution, right, of hive SQL queries basically, and which is accepting, which is starting your queries like as an entry point. Okay, so that's a driver is here. Okay, so which is accepting query and giving it to the compiler, and compiler is compiling the query. Okay, so if your query is compiled and there is no syntax error, right, in your query, right, so you will be convert the query to the execution plan. Okay, so this all things internally happen in the hive, and the compiler is doing that. It is creating some DAG, it's creating, and because queries is divided into the multiple parts, because we have a select, we have a from, where, we have group by, so different sections are there. So as per right query execution, right, because when we are doing the from clause, where clause, so all these sections will be broken, and it will be create a one tree or DAG. Okay, and then next is the optimizer. Optimizer will basically doing the optimization of your query. Like you are using some join query, you are using some like a simple select SQL query you are using. So the DAG will be like its optimizer will be doing the optimization. Okay, final executor is executing the query. Okay, so these are the three component, like compiler. So compiler, before compiler, parser come also. So parser, compiler, optimizer, and executor. Okay. So this is the basically converting query to the logical plan to physical plan to the MapReduce plan. And MapReduce plan is basically nothing but your MapReduce. It will be converted into the MapReduce job, and MapReduce job will be run by the Hadoop. Okay. So this is the architecture behind that. So there are the other core component are there in Hive, like Hive CLI is there. Hive CLI is command line interface. So whatever we are looking at here, this Hive CLI. So this Hive CLI is nothing but is basically command line interface. So where you can execute your query. And Hive UI. So user interface is the like Hue. If you have seen in the Cloudera, there is a Hue is there. That is the user interface where you can execute your query in the query editor window. Okay, and the thrift server, when you want to execute your query like cross platform, right? So when you want to access using the thrift protocol, okay, so beeline server is a thrift server, right? So beeline server, like you are not getting access of hive shell, but you have been given access to the beeline. So beeline is another CLI interface where like access is given to the user based on his credential. He can access beeline, and he can write the query, he can run the queries. Okay, so if we go to the hive shell, we can use an interactive mode or non-interactive mode. So interactive mode is when I'm just going to the hive, I just type hive and I go to the hive shell. That is a hive interactive mode where you can write hive queries and you can get statement by statement, you can get the result. Non-interactive mode is, suppose you have all the SQL queries you have and you write in a one file, and that file you run by command hive. if you write it command hive minus f, if you write the command hive minus f, f for the file, and then you can say test.hql. So my file extension is hql. So my file extension is HQL, I can run it. This is a non-interactive mode. So this will execute your file with the hive command, and then you can run all the queries in hive. This file you can run, okay? So features of the hive. So hive is having different like features are there, like hive is providing the partitioning, bucketing, Sardays, UDF, and hive is having an integration with Spark, Kafka, like all different. There is a Sardays are there different types of Sardays like Mongo, Cassandra, from any database or any programming or any visualization tool we can integrate hive, okay? Because hive is the storage, hive is providing the storage interface, hive is providing the HQL query interface to interact with the data on stored on the SDFS. Indexing, yes, Hive is supporting the indexing because it's a SQL feature, right? Indexing, view, all these are supported, right? Hive is supporting indexing, views. Okay, for view is read-only data, and literal view also we can use. Okay, so we can use all those things in the Hive. Okay. So Hive is completely following the SQL syntax. Okay, so that's the reason like Hive is supporting all the SQL features like windowing functions. We can use all group by aggregation functions we can use in Hive. And Hive limitation, if I say Hive is mainly used for the batch analytics data, not the real-time queries. Okay, so it's not having real-time queries data. Analytics is not there. So it's for the OLAP, not for OLTP. So when you want to go for OLTP, online transaction processing, analytics, online transaction processing you want to do, you have to go to SQL DBs. So SQL DB is having asset property and they are providing the OLTP, and Hive is OLAP, online analytical processing, like you are using as a data warehouse tool, like a similar to the Redshift, where you have historical data and you can do the analytics on top of the data which is stored as a historical data. Okay. So in Apache Hive, these are the things like we can do in Hive, like ETL support, data format, storage, file format, okay, different file formats, okay, as a warehouse, and Hive is having its own query language, declarative like DDL, DML, okay, so we can perform, and multi-user, right, role-based access authentication is there. So only specific role like user can see the tables, right? If I have not been given access, so I can't see those tables, or I have given the access on a specific column in the table. So those kind of role-based authentication access can be given. Okay, so it is not for the OLTP, no update. But now the newer version of Hive is update is there, right? Earlier version of Hive, like earlier version Hive before Hive 1.x version, there was no update and delete operations. So you cannot update the delete because Hive is providing the historical data analytics. So we don't need to go for like update or delete, right, operations. But the newer version of Hive, like you can have a staging tables, right? And then you can do update delete operations. You can do even the merge option you can do. Like suppose you want to merge the data, you want to do CDC, right? So there is a slowly changing dimension, right? SCD type 1, type 2, type 3, different types are there. So type 2 is basically maintaining the history version. So whenever you are getting a new record and you want to make it your existing record, like you can change a new version you can create. Okay, so that SCD type 2 you can maintain in Hive. Okay, so there is exactly you are not updating the same record, you are creating a new version of the new version you are creating for the new record. Okay, so that kind of way we can do the update and merge we can do. Or another merge table feature is there. So merge table is basically you can update the existing table from the source table or some new table data, you can merge it with your existing transaction table, you can merge. Okay, so transaction management feature is now available in Hive. Okay, so Hive is these features are there, you can go through it. So Hive architectures, I have already discussed about. Hive is having the client tools, like Thrift client could be there, some JDBC client could be there. Like suppose I have a Java JDBC program, I want to connect to the Hive driver and I want to access the Hive tables. So there is a way like I can create a one JDBC Java JDBC program. There I can get the result set. If you have seen the Java JDBC program, so there we have to connect with the Hive using the Hive driver, URL, username, and password. So we can get the data as a result set, and then we can iterate the data, and we can get the data. So that is the programmatic way. Thrift is basically, it's a cross platform, right? Like a beeline server, like as a Thrift server, we can connect to the Hive server, Hive engine, and then we can get our query executed and get the result. Okay. So JDBC, ODBC clients can be accessed. So Beeline and Hive server 2 and all will be interacting with the driver. Driver is then compiler, optimizer, metastore, and finally it is converting the MapReduce plan. And MapReduce is basically running a job. The data is stored on the SDFS. So the underlying storage is in SDFS. So where we are storing the data as file. Okay, these files could be a compressed file, or these are the human readable file like JSON file, text file, CSV files. So these data can be loaded into the Hive table. So I will talk about what are the Hive tables are there, like two types of table, internal table and external table. Okay. So Hive clients. So these are the client, means the interacting, like how can we interact with the Hive database? So Thrift client, JDBC, ODBC client, or Hive CLI, we can interact with the Hive database. Okay, so these are the all components are there. Metastore DB, Edge catalog. So suppose you are interacting Hive with some other analytics tool like Map. I'm just taking an example of MapReduce or Pig. So when you are interacting with from the Pig, you want to access any Hive table, there is a Edge catalog, like a utility is there. Edge catalog is a table, and it is providing Pig is providing to load through Edge catalog. You can read the Hive table, or you can write the data into Hive table. Okay, so Edge catalog is used like whenever you are using some different tool and you want to access Hive tables, right? So you can access through the Edge catalog table. So this is a layer on top of the Hive to access the Hive tables. Okay, this is some REST API similar to the SDFS REST API. So this is another REST API interface is there. You can access the Hive table through the REST API interface. Okay. So how Hive internally is working, like you are giving the queries, and then it is calling the get plan, and then get metadata, send metadata. Okay, so send plan, execute plan, and then submitting the MapReduce job. So finally, when the MapReduce is completed, then you will get the result, and this result will be given to the user on the Hive shell. Okay, so this is the steps, right, to do. So what are the Hive functions? So there are the two types of functions, like built-in functions and some custom functions. Built-in functions, which is given by the Hive. So I can say some functions are like a date function, string functions, number functions. So those are the categories of the different types of functions are there. Okay, some collection functions are there, like I have some list data, set data, map data is there, so I can do size is there, like I want to get the size of map, size of array. So this is complex data type. I will talk about there are the two types of data types are there: simple data type, primitive data type, and complex data type. So primitive data types, we all deal with the like string and int, float, double. These are the simple data type, primitive data type. But on top of that, another data types are there, like there is a complex data type. So I have a set of values are there I want to store. So I can use array, map is a key value pair, and another one is a struct. Okay. So I will show the example of those data types, how can we use. So these are the collection functions. So I want to get the values of the map based on the key. So I can find the keys. So I can use the keys function. I can get all the keys as an array. And if I call the values, so I can get all the values of particular key in the map. Okay. Date functions. So these are the all category of functions you can practice on that. Like you have a string date is there, and you want to get the year. You want to get a month, you want to get an hour. Okay, you want to convert to date, right? So any string value, string timestamp data is there. You want to convert to date type. You want to convert Unix timestamp. You want to convert. Okay, you want to get the current date. Like I want to get today date, current date. So I can use current underscore date. Last day function I can use. Truncate is there. So these are the functions, are the date functions. Mathematical functions are there. Conditional functions are there. Like I want to check whether the column value is null or not. So it will return the Boolean value. If condition, like that way we can do. And another one is a coalesce function is also there. Like you want to replace the null value with the other non-negative value, non-null value. So you can use the coalesce function. Okay, string functions are there. Very simple string functions are reverse function, rtrim, rpad. Okay, so this is the padding the space in the right side. Okay, split function is there. String to map, right? You want to convert like string data to the map key value pair data. So these are the all function categories are there. So you can find the examples. Just you have, if you know the function, these are all the like inbuilt functions. So you can take it example of this one. User defined function. So user defined function in Hive, there are the three types of user defined functions are there. Okay, so when I say UDF, so why we need UDF, right? So when I don't find, I want to execute some logic which is not having in the built-in function, so I write a UDF. So how to write a UDF in Hive? So I will write my custom function. So I can use a Java project. I can create a one Java application. Okay, for UDF, I have to create a Java application. So three types of UDF I was saying. So one is a UDF, user defined function, UDAF, user defined aggregate function, and user defined table function. So when I say UDF, UDF is taking one input value, one input, and one output value. Okay, one output value. So if I say I have the function lower, okay, suppose my function name is a lower one. Okay, I say I pass the value hello, or capital hello I'm passing because I'm making it lower. So I want to make it lowercase, right? So this is taking a one single input value hello and giving the single output value hello. So this is the UDF. UDF is taking one input and one output. UDF is taking list of values. It can take a complete entire column, right? I say Sally column is there. So Sally column has all number of different rows are there. I want to do the sum of Sally column. So this kind of function, so I can create a UDF function. So already some UDF functions are there, some average, but I can customize more in my Java class. So whenever you are writing UDF, so you can write your own custom Java class, and that will create a Java function. Okay. User defined table function, when you are taking input as a table and returning output as a table. Okay, so entire set of row and column you are giving as a input and giving output as a entire table. Okay, input is table, and output is table. Okay, so one explode function is there, that is and lateral view is there, explode, lateral view. So these are the category of UDTF, user defined table function. So how to create your own UDF? So first, suppose I'm just giving an example of UDF, right? One UDF is find occurrence. Okay. So find occurrence, I want to find one string is there, like a string one, I say, and one is a string two. So string one is my bigger string, I say, hello. Okay. In this string, I want to find the word hello. Okay, so there is no built-in function is there that can find the word, right? And find the occurrence of the word in the one other string. So I will create a one Java class. Okay, how I will write a UDF function. I will write a one class. I say my UDF find occurrence. Okay, and I will extend UDF. UDF is a class given by the Hive. And here I will override evaluate function. So I will be public. So here I want to return. Okay, so I want to return int type value, and I'm saying here evaluate function, and I'm taking as a text parameter. Okay, so I have value as a text type. Okay, so here is a string type. Text is a type. So string type value I'm taking. Okay, that is an input. So two input will be there: string text1 and text2. Okay, so when I'm taking the values, like two input values I'm taking, and here I will be using the regex, and then I can find the occurrence and return that value. So suppose it's how many times? 2 times. So it will return the count. So it will return count. Or otherwise, what I can do, or simple other way I can do, like my text1 is my bigger string, right? So I can split the data. So I say string array, and I say text1 dot split, and I will split with the space. Okay, and then I will iterate the loop. I say string s colon array, and I will write a logic here. So I will search it, right? So first I will start the int count 0, int count is 0, and I will say here, if I say this s dot equals my text2. So this is I have text2. Okay, so I check it with the text2 string. If it is matching, so I say count plus plus. Okay, and this count will be written as a count. This is the one easiest way. Another way is regex you can use. That is a one single line of command, like you can create a pattern and then you can do the matcher and then you can return count. Okay, so through Java regex, we can return that count, and this will be. Now the next thing is, when you have to, this Java class, you have to create a jar of this project. Okay, so we have to create a jar. Okay, we have to create a jar, and this jar I have to register on the Hive shell. So Hive shell, I will use add jar and give my UDF jar. Some jar is there. Okay, so I will register it, because any UDF function you want to create, the function will be the particular, this class is pointing to the your UDF. Okay, so you will be creating a one temporary function in the Hive shell. You say create temporary function. I say find occurrence, and as you will give the path of your class. So I say org example dot UDF occurrence. This is my class. So once you pointing out your class with the UDF function, now you can use in your SQL query, you say select, like I want to find. So my UDF function name is this one, find occurrence. So I will use find occurrence, and I gave these two strings, I will pass it. So you can use columns also, right? Like if you have the columns, so you can give the column name of any table, then you can do. Okay. Otherwise, you can do some dummy string you can give, and you can get the value. There is no from clause. Okay. So when you do this, you will return get the count too. Okay. If you have column, you can specify column, and from table you can give. So it will be giving you the result of that one. So this way we can create a UDF, and we can use it. Okay. Okay, I will show the practical of that. Okay, so UDF here, they said like simple UDF and complex API UDF. So same like the UDF is a simple UDF, like extend the UDF and evaluate function. You are giving input and returning the output. Okay, so you can write your own UDF, and then you can create a jar, and then you can create a temporary function. Okay, so this is the Java code for the UDF. Okay. So what are the DDL commands are there? So these are the DDL command mostly we use, like create. So create table, like show tables, describe, use, like use database, like generally database we use the use. Okay, and drop database or drop table. Alter we can use with the alter database and alter table, and truncate we can do the truncate table, right? So these are the command, like alter we can database table, drop we can use database table, use only for database, describe for both, show for database, table, indexes, functions, partitions. So everything we can do show command, and create we can use for the database and table both, and truncate only for table. Okay. So these are the DDL commands. So data definition language. So we can create a simple database first, like create database name. If not exist means if the database is not exist, it will create or it will drop and it will create. Okay. So create database, you can create a database. Okay. Show databases, it will be showing you the list of all databases. Okay. And describe databases, it will show the description about the database, like when the database is created and what is the location of the database. So you can get, okay, so database is created in your warehouse directory, or you have created externally some Hadoop location. So use database command to, because before getting the tables, right, so we have to use the database. So we have to use the database by using the use database command, drop database. So drop table and drop database. We can use alter database, like we can modify the database properties. So we can change the database location I want to change. So I can use the alter command. So alter the database schema. I can and we can use the properties, like the I want to change the create for, like who what the purpose of the database I created. So those properties I can change it by alter command. Okay. Honor and those things I can change. Okay. So DDL command, like create table. So create table, there are the two types of tables are there. Okay. First I explain it. So internal table and external table. So everybody is, mostly people knows about the internal table and external table. So what is the main difference between the internal and external? So internal is the table which is created within a warehouse directory, and it is managed table. And when you are dropping the table, when you drop internal table, so it will drop the schema and data both. Schema and data both will be deleted. Okay, dropped. Okay, but in case of external, so schema will not be dropped. Schema will be dropped, but data will not be dropped. But data will remain at the same position. So you can recreate table. Again, the create table command. Again, you can reassociate your data with the table schema. Okay. So here is a schema is deleted, but not the data. Okay. So external table is mostly used in the scenarios like where you have to map like this different tables with the same locations, right? So you can go for the multiple tables, you can go for like external table, you can map it. Okay. So internal table and external table. So if you see the metastore DB, so metastore DB, there is a TBLS table is there. So this TBLS table has the information about meta information about the tables. So whether the table is a managed table, so internal table is a managed table. Okay. And managed table. Okay. So this all information is stored here. Table type, table name, column names, what are the column names are there, and column types. Okay. So this information is stored in this TBLS. We can find or we can check also. Okay. But we have to connect that metastore DB, then we can check the information. Okay. So internal and external table. So I will show the demonstration of that. Next thing we will do partitioning. So what is the use of partitioning? So partitioning is a logical division of the data, which is distributing your data. Okay, for the same column, some partition column I will choose. Generally, the partition column is the column where the values are repeated. Okay, so you are logically dividing the data based on the column value in a different partitions. So you are going to avoid the full scan of the table. Okay, generally what happens when you write a where clause, right? When you write select star from table and write a where clause, okay, and you say city equal to xyz. So generally what will happen when this SQL queries will run without partition? It will check in the city column if the column value is this or column value is not this. If it is this, and then it will get all those records. So it will be checking each record one by one. Okay. So suppose if the less data is there, it is fine. It's not a problem. But if the data is very huge, right? 100,000 records are there and you are finding only couple of records. So you can think of how much time it will take, right? So there is a solution. Partitioning is the one solution, that is table structure remains same, and it will divide the data into logical division. So you have to first identify which column you are doing frequently queries, right? Which column, right? City column is there, date column is there, where you, so everyday data is coming and you are getting the data in the files, right? So suppose today you got some file and you are loading into the database that on the date basis. So you are creating a partition column is a date column. So partition column could be a date column. Okay. Partition column could be a city, country. Okay, like this columns. So when you are creating, you need a one partition table. So one partition table you need separately, one partition table you need on top of the source table. Okay, on top of source table, and you will query always this partition table. Okay, and this partition table has like create table, my partition table. You will be writing command like this, my partition table, and the fields will be there. Okay, like I have a id is an int, name is a string, and then you say partition by clause, and then you say city. Okay, and if you have the bucket, so bucket is the output file within partitions. So how we can understand the partition and bucketing? Like partition is the logical division of data, and bucketing is on other hand is a physical output file within partition. Bucket can be without partitions also there. Like you want to just generate the output files, but you don't want to divide the data logically, but just you done directly output as a files. But within a partitions, you want to create output files, that will be your buckets. And buckets using the hashing technique, right, to store the data, like it will generate a hash value. And there is a clustered by key is there. When you are using clustered by and say some unique column you have to give. Okay, suppose I say order ID or customer ID. This kind of columns you can use for bucketing. So generally we say the partition column should be repeated data should be there, and when you are using the bucketed column should be the column which is having the unique values. So that based on that unique value, your bucket should be defined. The hash value will be defined and it will go to the particular bucket. So within a partition, if you are not using bucketing, only partition you are using, only one partition will be there. If you are using only partition when you are using, only one file will be created, only one partition file will be created. Okay, in the partition. Okay, but when you are using bucketing, so here is multiple files will be created, and these are called bucket, are called bucket, are called bucket, physical's output file within same partition. Okay, so here bucketing is making it your retrieval of the data more faster than the partition. Suppose I say I want to get the data, select star from table, and I say city, I say xyz, and I say and customer id, and I say customer id, some specific customer id I want to find. So I want to get a data more faster, because when the within partition, it will check number of buckets and it will find for customer ID too. Okay, because I have already mentioned the clustered by key. Okay, this customer ID as my bucketed column. So it will go in that particular bucket and it will calculate hash value and find that bucket and get the record. So instead of you without bucketing, your data will be, you can get the partition faster, but a specific record in a partitions will be taking time. But by using the bucketing, it will be faster. Okay, so that is a use of bucketing. Okay, so we'll see that how we can do partitioning, bucketing. Okay, so those concepts will be, I will show table command. These are the basic commands: show table, describe table, like I want to see the schema of the file, drop table, I can drop the table. So these are all SQL statement. Alter table, like I want to modify the schema of the table, like I want to add a new column, I want to modify column. Okay, so we can use alter table command, or I can rename the table. Okay, so DDL command, alter table, or these commands we can use. Truncate command. Okay, what is the difference between the delete and truncate? So delete is you cannot roll back your data. Okay, you can roll back the data. In case of delete, you can roll back the data. Okay, because delete is allowing. But truncate means once you use truncate table, right? So your data will not be rolled back. So that's the difference. Okay. So DML commands. So DML command is basically we are reading, writing data. We are mostly the select, insert, update, delete operations we are doing. So these are the so DDL command are more concerned about the creating a tables, creating a database, creating a tables, creating an object, right? Create view, create indexes. So those things comes in the detail. But when we come to the DML, right? The DML is mostly are the loading data, selecting data, all CRUD operations, right? We can do with the DML. So load command is we can load the data from the files. So generally load commands we use when we want to load the data from file to the table, we use a load command. And insert command is used to insert the data from table to table, like some one table is there, source, and one is a target table. I want to load the data. Okay. So I can say like, suppose I have created some partition table, and that partition table, I want to load the data from some source table, then I can use insert into table and insert into table and select star from table I can use. Okay. So load data. So here is what is a load command. Okay, I just start with the practical so that will be more clear. So these SQL queries. So anyone has any questions so far?
My question is, sorry,
Mm. Yeah.
I tried doing something, but it wasn't working. Can you write your PySpark data frame, assuming you you are using PySpark, you read the data, then you did some transformation, perform some transformation. Can you write it back to a Hive
Okay,
table?
okay, but this session is not PySpark. Okay, we can read the data from Hive table, or we can write with the Hive. Okay, so PySpark we can integrate. Okay, yeah.
Okay.
Okay, I will take it when the Spark session I will tell. Okay, because we are concentrating on Hive only here, right? Only specific to Hive, like sequels.
Oh,
Okay. Hmm.
okay. Thank you.
Yeah. Any question related to Hive you want to ask? Okay. So one ebook is there, you guys can follow. Okay, I have mostly following. This is a Hive essential book. Okay, so okay, this is a source code of this book. This is a packed publication book, and it has around 10 chapters are there. Okay, 10 chapters are there. So it has script and data. So when you see here, this is the GitHub location. You can directly check out this code and data, right? So data is having the tables, right? The data, right? So these are the text-wise data is there. So that will be used entire this book. They have used this data, and the script is having the HQL script, right? Hive scripts, right? Hive commands. Okay. So I have already I've copied here in my notepad. So I will be showing the commands. Okay. So you can go through the book also. The book I will provide the book, or yes, free available also. Hive essential ebook free download. So this is this is a book. Okay. So this is some Chinese writer is there for this book. So this book is the have everything. Okay. So like a UDF and everything is there, right? Data manipulation, data SQL queries, table creation. So everything you can practice, right? Inner join, left outer join, and every SQL queries are given. Just you have to use the commands and then you can practice. Okay. So in Hive, like when we are going to create a table, right? Okay. So when I'm not specifying any external keyword, so that table is internal table. So if I say this create table employee, and this table is a complex data types are there. If you see here, the name is a string, workplace is an array type, and gender age is here is a struct type because it has different data types are there. So struct means when the data types are different data type values are there, like gender is a string and age is an integer, right? Or you can say address, right? Address is a struct type, where is a street, city, okay, and the zip code are the different data types are there. Okay, so there you can use array is all the values are a string type, like marks, like student marks I want to store, so it's an array. Okay, so some values which is like a same data type we use array. Struct is different data types values are there, and map is only key and value association is there. Okay, and this is map and nested array. So if I say the key is a string, but value is array of string. Okay, so here the department titles can be more than one, right? So for one key, for multiple department titles are there as a array. Okay, so this is a nested data type, right? Nested complex data type. So here, if you see how we create a table, generally, if you want to create a table, we use row format delimited and field terminated by comma. Suppose my data is a comma delimited format, okay? And then we do store as text file. But here in the complex data type table, we are specifying the two more property, okay? So I'm saying my fields are terminated by pipe. So if my fields are terminated by pipe, so I have to use some other delimited character for collection. So that I have to check in my input file. Okay, so if I go to my data, so whatever the data is defining, okay, this is employee.txt. If you see, the fields are terminated by pipe. So this is a field are terminated by pipe, but internal data is separated by comma, right? If you see workplace, it is some comma separated. It could change. Suppose your fields are terminated by comma and your collection items are terminated by pipe. Okay, so whatever delimited character is there, you can use that delimited character. So here is fields terminated by pipe. So if you see here, the fields are terminated by pipe, collection item terminated by comma, and map keys are terminated by colon. Okay, so this is parsing, like this is the parsing logic. So this is basically when I'm defining in my complex data type table. So there I have to specify how arrays value will be passed, how struct value will be passed. So arrays and struct both are the collections. Okay, so that we can use collection item terminated by, but map is having key value pair, and key and value is only two things, right? So we have keys are terminated by colon, but again the collections will be there in this department title, that will be comma separated values. Okay, so I will create a table, I will load the data into the table, and this table will be created in the warehouse directory because I'm not giving any external keyword. So if you are not giving any external keyword, so your table will be stored in the warehouse directory, that will be managed table. Okay, and when you are giving external table, so external table will go to the warehouse if you are not giving the location. If you are giving the location, then it will store to the outside the warehouse. Okay, so the only difference is here in the external, you can give the location, or if you don't give the location, it will go to same warehouse directory. Okay,
Excuse me, are these case sensitive?
what?
Are they case sensitive?
No case system, right? Like basically this table clause, right? You are saying employee capital or employee small, you can give.
Or even the string?
Oh, this one, this string,
Yeah,
you
yes,
can
yes.
type it capital small, as capital as small is not a problem.
Okay, okay, okay.
This integer you can type all capital or small int is not a, so data type, right? Is case insensitive. Okay. Okay, why this error came? Because immediately Hadoop I started and immediately I started Hive. So it will be in the safe mode. So when you 25-second, right, it will be turned off. Either I should wait for the 22-second, then I start the Hive. Otherwise, whenever you are doing any command, immediately starting the Hadoop, you will get this error. Okay, so the other option is there. It will wait for 22-second. If you want to immediately come out from the safe mode, there is a command sdfs dfs admin minus safe mode leave. Okay, if you want to just immediately you do this and then you start Hive. So you will not get this error. But you are getting this error because you quickly started Hive just immediately after starting your Hadoop. So it takes 22-second time to start your Hadoop services. So it allows to run any command, right? Hive you want to start, or you can do some, suppose you want to put a file in the Hadoop directory, you can't do. So like within 30 seconds, you can't do. Okay. Okay. So when I'm doing the show databases, so these are the databases I have already. Okay. So one is the default DB. When you create a new, when you install Hive, so you will get only default. Okay. You will get only default. Okay. But in my case, I have already created other databases like MyDB, testing, workshop. So these are coming. Okay. I create a new database, create database. Just I create this database and now I have to use the database workshop one. So now if I going to check the table, show tables, so I will find nothing because I have no table. Okay. So now I'm going to start. And what I did, this data. So this data I kept it Hive essential data. So my all the data I already kept it. So you can make it some directory. Okay. So you can make it some directory where you can keep it data. Okay. So you can, so this is the Hive essentials. So Hive essentials, this folder, and this is having the data. Even the script is also here. I can open a script and I can run it. Okay. So this data is having the data, right? These are 4 text files are there, which is given by the this Hive essential. Okay. So now it will be easy for me to run the command, right? I have to change the location here. So I will, when I'm loading the data. Okay. So first I'm going to create a table. So create table employee. So I'm going to create a table. Okay. So if you want to see the table structure, so okay, if you want to see only column to describe employee, you can see. So you can see another is describe employee extended. There is some little changes there. One command is there, show create table, and then you say employee. Show create table command, what it will do, it will create table syntax, it will show to you, it will show what are the columns you have, what is the table location. So if you see, this is the internal table. So internal table is going to the user Hive warehouse, and there is a workshop1.db. So one database folder is created, and that folder having another folder with your table. So this is not a file, this is the location of your table, and here the data will be stored. So in this folder, the file will be stored, and that will be pointing to your data for your table. Okay. So right now, if I do select star from table, okay, so I will not get any data because I have not loaded any data. When I say select this one, so I'm getting no data because just I created table, just I created empty table. Okay. Suppose you want to see in this location what is there. So you can run the Hadoop command also by using exclamation mark in the Hive shell. You can do Hadoop fs minus ls slash, and I can give this location. This is my Hadoop location. I can run the Hadoop command. I can run Hadoop command on the Hive shell. So I paste this. So I will see this is empty because there is no data is there. Now the next step after creating the table, the next step, this is just for verification. So this is load data local in path. So there are the two commands are there. One is load data local in path and one is load data in path. Okay. Suppose my data is my Hadoop file system in some other location. So then I will not use the local. So when I have data on my Hadoop file system, some location. Okay. So this particular file, not in the local file system, it will be some in Hadoop file system. So suppose I say my data. So some folder is there in my Hadoop file system and this file is there. So this is a one-step process, because here what you need to do, you have to put the file in Hadoop file system on this location and then you are writing into table. But here load data local in path command is an easy command, right? In a one-step process. Whatever location you have data in your local file system, directly write into the Hive table. So you use load data local, but just you have to use local keyword. So local in path and give your location of your local file system. Okay, and then override if you want to have already data in the table and you want to override it, then you use override. Otherwise, if you want to append the data, so there are the two modes are there, append and override. So append mode, when you want to add data in increment mode. Okay, so data will be keep appending, because in Hive there is no primary key concept, right? So you know in the SQL databases primary key is there. So when you try to add the same record again, you will get the constraint violation exception on the primary key. But Hive will not give any error, right? Because Hive is not having any primary key concept. So if the same record you are doing, it will keep appending. So append mode is adding the data again and again. So your data will become duplicate. So that is the reason we have to remove the data, duplicate data manually. Okay. So generally we have already some data and I want to avoid duplication. So I will overwrite mode I will use, so that my data should not become duplicate and it should be overwrite. But suppose you say you have in your new data, you have some new record or some existing record. So in that case, what you should do? You should use merge. In that case, you should use merge, so that your existing record will be there, but the your existing record will be updated and the new record will be inserted. Okay, so that way we will be doing. So append mode is always adding the new data, and override will existing data will be overridden. Okay, but suppose you are doing existing data, you want to overridden in the partition, so only that partition will be overridden. So generally, suppose you got some file today, okay, and you are loading in the partition table for today date partition, but the job got failed. So again, you are loading the data in the same partition, so it will override the data. So whatever data is present in your partition, only that partition will be overridden. So generally, the partitions we will be always override. Okay, but the whole table we cannot override, right? Because my existing data will be removed, right? Okay, with the the new data. Okay, in that case, we go for the merge. So local in path, when I have a file in my local file system or when I file in my Hadoop file system. So when I have local file system, I will use load data local in path. And data will be inserted very quickly. This is a schema on write. So there are the two concepts is there. Hive is schema on read. Okay. So schema on read means the data will be validated. At the time of select query, or we can say reading data from SQL query. Okay, from the Hive table. Okay. So reading will be validated data, but writing will not be validating. So writing is faster in Hive table. Okay, Hive table. So bulk data like huge data, you can write quickly in Hive table. That is the advantage. Okay, and SQL databases are schema on write. Okay, what is schema on write? Schema on write is the data is validated at the time of insertion, in the table, insertion of the table. So you have seen whenever your data type is wrong and you are trying to insert data in some SQL database table, it will give you the error. It will not allow even the single insert statement. But here, the SQL insert statement will not fail. The loading data will not be fail in case of hive, because it is not validating any data. It will insert as a null, but it will not fail. Okay, so that's the thing is there. So insertion is very, very faster in the hive. Okay, so SQL database is a schema on right. Okay, so I have inserted data. Now I want to check my table. Okay, first I check my this command to check whether any file came or not. Okay, so I will check employee.txt file is copied. So when I use load data command, so my file is copied in this location, and now it is pointing to the my table data. Now I do select star from table. Okay, select star from employee. So I will see my data is there. So this is a complex data, right? So this is the first field. This square bracket is a workplace, that is a second field, and that is the array type. Third field is gender age, that is a complex data type struct, which is a combination of two different data type. One is a string type and one is a number type. This is a key value type, right? Which is like a key and value. And the one more is key and value, but the value is again array type. If you see here is a single value, here also the single value. Okay, here also the single value is there, here is a single value. So it can have multiple values can be also there because it's an array type. Okay, so suppose I want to read this data. I want to read the particular index data or particular like object values data, so I can read it. Okay, so how to write a select queries? So select queries, like if it is an array type data, I have to use index. Like I want to read a 0 index or first index, and I can say, so if I say, so if you want to get all the data, so just use select star. But if you want to get a specific data of a particular column, so you say here. So here, if you see the first column values every row is having, then second one is having only for the first Michael, but other one is not having. The third one is there is no data at all for anyone. So that is the reason it's coming null. Okay, so we can get all the different values of the array. Okay, so how to take the values of struct type? So struct type, we have to get it through the column name dot the particular values, right? Okay, suppose I say the two columns are there, so gender and age. Okay, so gender age dot gender and gender age dot age. Okay, so I can access. Okay, so I'm getting the value. Okay, for each record or specific record, just use where clause and you can say some where clause. So a specific row only you want, so you can give the where clause. Okay, it's similar to the SQL. Like here is I want to get the key. So how to get the key? How you can give the key to your map? Skill score is your map, and the key you are giving like this. So you are giving the values. Okay, so you are getting the values through keys. Okay, so wherever the values are not there, those data is coming null, because here the first record only this value is there, db value is there. So when I say db has 80, but the other values are not there for db, right? For this Perl value is not there, for this one is not there, for second one Perl is there. So other values are coming null. So that way we can access the key and value. So we have to give a square bracket. So we have to give in the array, we have to give the 0, 1, 2 indexes. But in case of map, we have to give the key name. So key name, it will get the value. Okay, so that is the map. Okay, so we can get it like this way. Okay, so I want to create a database, I can create database, or this one I can find, I can create database if not exist. So these commands are there. Show databases will showing the databases. You can use regular expression. You can say like, and you can say, I want to see the databases are starting with the some specific word. So you can use like this, show databases. So these are the So workshop 1 is coming. So this is just searching, right? Searching things, right? You can do. So describe database, you can get the, and you want to know which database you are currently now. So here I'm not able to find in which database now, because this is a Hive shell. So I can use current database. So I can come to know I'm in this particular database. So I have used this database. If I change this another database, so current will show that particular database. Okay, so alter database, this I already talked about, like set properties, like we can change who is edited by. So this anybody's name you can put, and then it will alter. Okay, so another table I'm creating. Okay, so this is the load data command we do. Okay, we do one practical of internal external. Okay, so I'm going to drop this table, drop table employee. Okay, this is the internal table, right? So when I drop this table, now I check my location, whether my table is present or not. Okay, so my location, the data is gone, like this employee folder is deleted. If I check till workshop1.db, so I will find the employee folder is not there. So far I created only one table, so that table is gone. If I do select star from employee, so I will see table not found. Okay, so internal case, like my table, like data and my data, and as well as my schema, both are deleted. If I create the same table as a external table, so if I create an external table, I just use external and I create a table, but this table will go to the warehouse, but data will not be deleted. So that's a use case basically. Okay, so I have created this table. Now I'm loading the data. Now I'm loading the data in a different way. Last time I used the load data local in path command. So instead of that, in this location, what is the location of this table? If I put that file, I know the location of this table, right? I know one location is created, right? One folder is created, employee. If I copy my file directly on this location, my data will be populated in the table. So what I do, I just copy this path and I use hadoop fs minus put command. So I do pd data. So here is my employee.txt is there, right? That's the data for this table. Okay, so I use hadoop fs minus put and I say employee.txt and I give this location where I want to write the data. So I'm directly putting the data on the location in employee folder. Okay, I have write the data. I didn't do any load data local command. Now I do select star from table. Select star from employee. So I will get the data. So this is another way you can put the file in your location of the data, whether it's external location, some outside the warehouse directory or within warehouses. Now, if I'm going to drop this table, okay, drop table employee. Okay, so if I do select star from table, I will get error, table not found, because I deleted table. Okay, and if I check my location, okay, employee folder is not deleted. If I see the file in this one, if I see employee, I want to see inside this folder, I'm still having the employee.txt. So external table is just making de-associated, like you're dropping the table, external table is de-associated your data to the schema. Okay, but the data remain on the same position. So again, if I create the table, if I copy this command and again run, okay, and now I do select star from table. So I will see my data is there. So data is already there, just I have created table again, and now my table is populated. Okay, so my table is populated with the existing data present on the same location. So this is the like internal and external table difference. It is clear. Okay, so and what you're seeing like load. Okay, so just I noted down here, like we see how to load data. Okay, so two ways are there. One is load data local in path, and one is Hadoop fs minus put command to write data into your hive table folder. And this is the external location folder or warehouse directory. It could be anything. So you can find out like if you have done the external table, if you have created, then you can use show create table command. So show create table command. So show create table command. Show create table. I already have written here. The show create table command, you can see where is your table folder, and then you can put the file. Okay. Any developer command use there, then you can use the exclamation mark. Okay. So partitioning, now we go to the partitioning things. Let's see that what else is there. So okay, this is external table. Okay, same table they created external table. Okay, we can create some temporary table. So temporary keyword is there, so we can create. So create table, like one table to another table we can create. There are the different ways are there, like you can do as select star from table. So it will populate the data from one table to another table, right? You can populate the data as well as it will create a schema, everything. Okay, so I want to create this temp table employee, and I say I have a employee. So I create this temporary table. So create table as select command. This is a create table as select, CTAS. So create table as select, you can use with clause. You can say create table CT, and you say here with, you can give the different aliases. Suppose you want to create 3 tables from one existing table based on the different criteria. What is the one criteria? One criteria is you want to say the name is Michael, only that those names you want. Second table is you want where the gender is the male and when the gender is the female. And then you can do the union all. You can combine the result rows of the this R1 and R3. So these are the different sequels you can write. This is your table. So if you want to see the schema, show create table, table name. So same table schema. And if I want to see the result, I want to see the data of this table. Same data, right? So this way, like you can, sometimes you want to take the backup, right? You want to create a one backup table, right? Or you want to data with the schema or only schema you want, right? So you can use different ways. Okay. So like clause is there, CTS. Okay. So you can give the some conditions, you can define show tables. So show tables is also having regular expression, like you want to find the table which is starting with the some specific characters, you can say, or you can say the or condition, you can say with this name or this name. Okay, so these are the, so extended is there, you want to, okay, so you want to see show table extended, maybe right now. So you have employee only. Extended is basically giving you the more information about the table, like table partitions, table columns. So all those information you can get it using the extended about the locations. So either you can do show create table, or you can do like here also you can get the information about the table. Okay. So drop table, this we have already seen. Truncate we can do. Okay, so this you can try truncate. Okay, so it will not hold back the data. Rename table, right? We can be. So these are all alter table command. So alter table like rename, we can change. We can set property. We can change the comment. So for any table, we can put some comment, right? What is the purpose of this table? So we can add some comment, or we can field delimited character I want to change. So I'm using the field delimited character pipe, right? So I want to change it to dollar, right? Suppose I'm getting a new file with the different delimited character. So I can change later also. I can change the delimited character. So set property is the way to change your table properties. Okay. You want to change your file format. So generally when we are creating a table, we are defining the stored as. So store is a text file, ORC file, Parquet file, Avro file. So different types of file format, you will define the stored as. So when you want to change this file format, you can change it by using the file format, and you can set the new file format. So for a particular table, you can change. You can change the location. Sometimes you want to change the location, like you want to create some backup location of your data of your table. You can use the set location. You can set a new location. Okay. So sometimes your data is arrived on some location and you think, okay, this particular location should be pointing to your data for the table. So you can set the location. Okay. And sometimes you want to put a restriction on the table, like nobody can drop your table. So you can enable no drop, disable no drop. Okay. So offline you want to see, or disable offline. So these are the properties we can set. Okay. Okay, so these are the command and describe commands are there. I can and change the column type you want to change. You can change the column type. Okay, so you can change keyword is there. Okay, so we can change the column type. Replace column, replace all columns. So replace column name. Okay, so these are the alter tables command. Okay, so create a partition table. How to create a partition table? So partition table is a table like where we have some partition by column. So here partition column is a 2 columns, nested column. So year is the first level of partition and month is the partition within a year, right? So sometimes you can have only the date column, right? You say today date, right? So 2023 0406, right? Like this is 0604. So today date partition is there. Then next day. But another way of managing the partition for the date, like you can have one column and inside that another column is nested column. So 1 year is 2023 and 2023 have the 1 to 12 month, right? So 01, 02, 03 like that. And then further you can have the like month wise data, right? So you have the files are there. So partition, we can use the partition by clause and then row format delimited. And this is the same thing, whatever you are using in the normal table, right? Okay. So when I want to create any partition table, I can create a partition table. Okay. And now this partition table need to be public. So I want to see how many partitions are there. Okay. So far this show partitions command. Okay. So describe command will show the information about the partition table. If you see, so describe command is same whether you do for the normal table or partition table. Just extra these two partition information will come also, extra partition information, which are the columns are there as a partition column. And when you want to see how many partitions are there, so there's the show partitions command. You can give the table name and then it will show the partitions. So right now partition table you just created, but you have not added any partition, right? You have not created any new partition. So suppose I want to add the partition. So alter table, add partition command, alter table, add partition. So if I'm using the partition columns are 2, so I have to specify both the partition. So I'm saying 2018 is my year and month is 11, and 2018 is a year and month is 12. So in the 2018 year folder have 2 folders, one is for 11 and one for the 12. So I can change the partition. Okay, and now I want to see the partition, but this partition is still empty. Just you created the folders, partitions you created, but this is the empty partitions. Okay, you can see here. But command, like suppose you want to see the table structure. Okay, so when you see the show create table, like okay, you have the location of this table, show create table. Okay, I want to see this partition, this table location, and I want to see the partition on the location, SDFS location. So this is the partition table. So I go to this partition table location. So I use Hadoop fs ls command. I will enter. So here I will see the first label of partition. The first label of partition is year 2018. Now I will add this year, the partition column, and the value 2018. Now inside this one, I will see two more partitions, one for the 11 month and one for the 12 month. So when I say slash month equal to 11, so just logical structure is created, but there is no data. So this will be empty because I have not loaded data into this. So there are the two ways are there. We can load the data into the same partition or like table like we use load data local path command, or we can use Hadoop fs minus put command. So we can load the data into partition. So if I want to load the data into partition, we can load command, load data local in path. Okay, so local I'm using because I want to load the data. So this employee.txt file I'm loading into the partition. So I'm using into table. Till here it is same command. Just I have to add an extra keyword partition and give the partition value. This is a static partition. Why it is static? Because you are loading data manually. So dynamic partition is automatically your table has the data and it will create the partitions. Okay, so that is called dynamic partition. So static partition is a manual partition where you are loading the data into partition manually. And dynamic partition is it automatically distribute the data into number of partitions depending on the values in the column. Okay, so here is you are loading data local in path and you are giving the file. So this entire file will go to the one partition. Okay, so suppose you have another file is there and which has a different data. So you will load with the different partition, right? If you are not using override keyword here, and if you use the same partition, what will happen? Your partition data will be keep appending. Okay, so when you are you want to using the same data and again you want to write, so you should use override keyword. So when I do this load data local path command, okay, now I want to check my folder. I have loaded in the 12 one, so I have to check 12, not 11. So you see employee.txt file is just copied there. Okay, and when you say select star, so how will you get the partition data? So you have to check. Okay, now we check show partition command, show table, show partition. So partition are still two only. Okay, because you already created logically, but the data is inserted only in the 12th one. 11 one is still empty. Okay, so you want to select query you want to see. So how will you do? Select star from, and then you say the table employee partition where, and you have to give the both the columns value. Year you say 2018 and you say month is 12. So you will see the data is there, but you see month 11, there is no data. So in this partition, data is still not there. Okay, or you want to just remove this where clause, whole data you want to see. So all partition data will come, right? So if you are not giving the partition columns, so all data will come. Okay, it's no matter what partition is this. Okay, but when you are giving a specific partition column values, okay, so then a specific partition data will come. Okay, so you loaded data into one partition and then like you are getting the data. Okay, so or other commands also there, alter commands are there, like you can rename the partition. Okay, alter table, drop partition. Suppose this partition is no use, I want to delete it. So I'm not using this partition, I can delete. So if you delete this, okay, sometimes you are removing the partition. Suppose you are some already you have this data, but you are removing the partition. Okay, now you do the select star from, because you have dropped the partition and then your data is also removed. Okay, 1 second. Yeah, because it's not showing any data for the 12 partition, right? 11, 12, because if the whole table doesn't have data means it is not. So when you do alter table drop partition, it removed your partition as well. Like logical and physical both is deleted. Okay. So when you are using like a drop partitions, a drop will. So some other way also you can do, if you give only first partition, the outer partition you are giving, so all inner partition will automatically drop because that is the part of the folder. Because when you are removing the year 2018, so all month will be deleted. Or when you are saying month, particular month, you can drop only that specific month one. Okay. So this is a just like which level of partition you are going to drop. Okay.
Arvind, this day, if we want to partition the data on date, each day wise means we need to
Date column. So you should have date and you say like, okay, my date is there. Okay, I say my date that I will be creating some string date column. Okay, and I say my date column value is like date. Okay, so date I say, and I say 2017 single quote 2017 0909, right? Like this. So this is my date. Okay, so this is a single column because here it will be not multiple, because when you have two columns are here in the partition, then only it is nested. It's a single date value, right? 09. Tomorrow the data comes, so you will have 2017 09 10 11, right? So one folder will be there for each date. Okay, so this is the date one. Okay, but here I'm saying I want to manage this data in a more micro way, right? Like, okay, suppose if I want to delete a specific month, a specific date, you can easily delete here, right? But here is a problem, right? Because here all data in a single folder and it's like in a one single partition, right? All the date data, right? Okay, so this is a more manageable way. Even we can go for the year, month, and day, right? So every day wise partition. So suppose you want to go for a specific month, a specific year, and a specific day. Just remove that drop partition you do, your data will be removed. All for the date. Okay. So you will not get the data for that particular year, month, and day, right? Okay. Okay. So here you cannot drop the entire date, right? Because if you drop the complete, right, so entire date will be deleted, right? Okay, so we cannot do that. Okay, so a specific day, month, year, we should go for nested partition, like year and the country and state or city. So I say particular city data I don't want. So I will go for country, state, and city. That particular city I will remove. So I can give directly the city. Okay, so then I can remove the one like this way. Okay, so it will check whatever city is there. Okay, because city is a unique, right? If this city will not be in other partition, right? It will not be there, the city, right? So then I can find that city and that city data will be removed. Whichever partition it's belonging, or maybe it's a duplicate also. So wherever it is there, it will be deleted from all the partitions. Okay. Rename we can do. So suppose I want to change the partition year, month, because I wrongly inserted partition and I realize, okay, my partition month should be 10. So how to correct it? So it is like rename command is there. So it will make it change here 12 to 10. It will change. Okay, so it will change. Okay, so these are the easy commands. So okay, so like here, like alter table partitions also, like change the data type also. Suppose I realize, okay, my partition column type, like I have made year is an integer. Now I want to make it a string. So I can do those modification. Okay. So I can also allow the enable no drop on the partition, right? I have location, file format. So same thing, whatever you do, normal table you can do for partition, just only you will add this partition clause, because you need to tell which partition, right? Because partition table you have to specify partition, because partition table is representing through the partition, right? You cannot represent as a whole table, right? Okay.
that set location, if we are giving default set location, we are changing to this path or no?
Set
Usually,
location is,
we are not giving any path, it will go to warehouse path, right? That
yeah,
warehouse.
set location is like if you are setting manually external path, so it will go to that location. That will, so external table you can, it doesn't matter, right? Okay, it's completely depend on the location. So external means external behavior will come, like when you drop table, so your data will not drop. Okay, so that behavior will come as a external. Okay, otherwise location will decide whether the data will be stored in the warehouse or outside the warehouse. Okay. Okay, somebody is asking like integer one, right? Like, okay, so it will not give the problem in the change the data type. Okay, but when you are doing the query and you have some string column type, you are accepting anything. But if you have some other data type, right, like integer, and you are trying to get string, it will be number format exception, right? So while reading data, you will get the error. Okay, while reading data, you will get the error, but change data type, it will not get the problem. Okay. So generally, we should make sure whatever data type you're going to change, like that should be compatible type, right? Otherwise, when you are selecting data, then you will get the error. Okay. Okay, so here, like other tables also there. Okay, we create these tables. So bucketing table. Okay. Now the next concept is how to create a buckets. Okay. So this is a one table which is not having any bucket. Okay. So here I'm not using. So when I create a here table employee ID buckets. So here I'm specifying clustered by key. So clustered by, and I'm using employee ID. I told you the unique ID column I have to use, and I'm saying into two bucket. Two bucket means suppose you have a 10 record. How many record will go to the one bucket? 5, and 5 will go to the second bucket. So your records will be equally divided, right? So your first 5 will go to the one bucket and second bucket. Yeah. So there is a calculation also, you can decide like how many bucket you want to decide, but how many files will be created. So you can set the property map reduce task 2. So when you are setting this property, your output is distributed into the 2 files. And there is a one more property you have to set, enforce bucketing true. So these configuration property you have to enable, create a bucketed table and load the data. Okay, so here, if you see here, I'm inserting the data into bucketed table from the normal table. So first I loaded the data. Okay, this is my source table, this one employee ID. So I create this table. Even from the file also we can load the data, or we can load the data from the table. Okay. Okay, so this is the same location. This file is there. So this is the normal table. This is not the bucketing table. Okay. I loaded data in this one, and I'm creating now the same columns. Just only I add this one clustered by. Okay. And it is not using the partition. Okay. Or I can use partition by. So it will be using partition first and then bucket inside the partition. But I'm using without partition. So, but we can use partition by clause. We can keep it here. Okay. So partition by, we can give the column value which is repeated. Okay. So some column we can use. Okay, so this is my bucketing table, bucketed table. And here now I'm saying these two property. Okay, if I try to do without setting this property, what happens? Okay, let's see. Okay, I'm doing insert override table. Okay, or insert into also you can do, because this is the first time you are loading data. So first time data, you are not worrying about the data is overwritten. Okay, so select start from. So this is a map reduce job is created. Okay. So now I check my bucketed table, right? So this table is my bucket table. So I check the location. So how many files are created? Show create table. Okay. And now I check this location Hadoop fs minus ls. You remember, right? I didn't do those two property, right? The bucketing properties I have not applied. So it has created 0, 1. Okay, because the number of buckets I specify, but data is equally distributed or not. Okay, let's see. So here in the first one, because in the create table syntax, we have into 2 bucket. Okay. Because of that, it created the 2 folders, 2 files. Okay, so this is the first file, and I'm doing the cat command to check the content of this first file. Okay, so my data came on this. Second one I check 001. Low. Okay, here is the one. This is the one. So data, what happened, right? Data is, I think whole data, right? This is data is same data, right? 1, 2, 3, 1, 1, and 103. 1, 2, 3. How many data, how many records are there? Okay, let's see the data. Employee underscore ID. 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 20, 24. So 12 records. Here are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There is a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 records is distributed. Even we are not dividing that, it has done based on the this, right? Here is a clustered by key. But generally bucketing property we have to enable. I have not run these two property. Okay. So if I want to change further, I suppose I want to distribute into the 3 reduced tasks. Okay. Now I said this. The hive. And I'm loading data again. Insert override. So reduced task is basically the number of output file. Yeah, right. 0, 0. So it is okay. This enforced bucketing. not changing. Okay, it's not changing. Okay, let's see. So this bucketing column, okay, this is basically defining the number of reduced tasks. So how many output file will be there in the the table location folder. Okay. So this way we can do the bucketing. Okay, so bucketing is basically creating a multiple output file depending on the number of bucket you have created. You have given the in your create table syntax, so it will be changing the number of output file. Okay. Okay, so next thing is create view. Okay, so view is like it's you are getting the data from the table and creating a read only data. Okay, so we create a view. So suppose I have some table columns field. I want to get a specific all data, this table columns, and then I want to create some view. So I can create a view. So I can create view. And I want to see the show views and this all the commands, right, to see. So show create table command for the view, you can see the syntax of the create table view. Okay, so you can see. So this is the create view command. You can see the view syntax. Okay. So this is simply the same like for table you do. Suppose you do alter view and now you are doing alter view.
Sir,
Hello.
hello.
Yes.
Sir, I have one doubt, sir.
Mhm.
You said bucket number is cluster by ID two bucket. You said that it's right. Then why
Mhm.
you said that reduce job is 3, sir?
3, suppose if I want to change the data into more number of buckets, right? Because once I create a table, right, I want to set the bucket. I want to change the reduce task, right? So reduce task will change the number of bucket.
Okay, okay.
Okay.
If
For
any application in future use that map reduce task is 3 or otherwise how much number of you want it to put there, right?
so the reduced task will be based on reduced task, it will be reducer, right? So and those many number of files will be created. That's logic, right? In the map reduce job as well as in the hive also. So whatever reduced task or you are defining the number of buckets, so that will be output file.
Yeah, okay.
Arvind, is there
Mhm.
any relation between that output reduced task is equal to that the buckets which we defined, or the buckets defined is based on how we are defining that buckets?
See, this bucket can be changed. Okay, maybe some configuration things we have to do more. So this bucket, right? Like initially I defined 2 buckets, okay, but later point of time I want to change, right? So I can set the reduce task. Okay. So generally, if you know already, right, like how to decide. So there is okay, if you want to check like how to decide the number of bucket. So based on the
Total
table,
volume of the data.
how to decide number of bucket in the table in Hive. So there is a one this Stack Overflow, you can read this. So suppose your table size is 2300 MB, okay, and your block size is the 128 MB. So you will divide this, so you will get the total number of blocks. So that is coming around 18, okay, and you will check 2 key power n is greater than 18. So you will find that 2 key power 5 is greater than 18. So 32 buckets will be there. For this much data, the 32 is the ideal bucket. Okay. So if you're, because this 2300 MB data will be divided into the 32 equal size of the bucket. Okay. So like a depend, right, how many records come in 2300 MB. This is the 2.3 GB data, right? So 2.3 GB data may be 10, like it will be like we cannot say like exactly the how many number of columns you have. So depending on the columns and rows, right, your data will be defined, right? So the exact formula is like you find the total size of a table, find the block number of blocks, and check the number of blocks are like your bucket number of buckets should be greater than your number of blocks. Okay, so 32 is a number. If you have here the 14, so you can say 2 key power 4 is fine, like 16 bucket is fine. Okay, so that way you can find number of bucket and you can use in your create table syntax. Okay, clear. So this way you can, so this number of buckets, like we can do sometime tuning, right? Because I cannot say the ideal number of buckets like it should be, okay? Because sometimes the performance will be degraded, right? So I should find the exact number of buckets. So generally this calculation, if you do, so you can say, if your less data is there, suppose you have a 10 record, so you will not go for 32 buckets because it's no point, because more than 10 bucket or one record you are storing in one bucket, so that will be no point, right? Okay.
Yeah, Arvind, can you go back that Stack Overflow?
Yeah.
Yeah, here the total size divided by our block size, then we'll get that 80.
128 MB is a block size. This is Hadoop 2.x.
Yeah.
Okay, so total 18 number of blocks are coming, right?
Okay.
Good. And 18 number blocks is basically if 2 ki power 5 you do, right? Generally the buckets will be in 2 ki power, either 2 ki power 1, 2 ki power 2, 2 ki power 4, 2 ki power 5, 2 ki power 6, like this will go. Okay. So 2 ki power 4 is less than, right?
60,
18.
yeah.
Yeah.
Okay.
So you find the total number of buckets. 2 ki power 5, 32. We don't the size of the data initially. Okay, if we don't know the size, like we can find the data size, like a complete folder size you can see, right? Okay, so data size is like the entire folder of the table, right? You can check on the Hadoop. So Hadoop fs minus like a du command, you can see dus command, or you can check df command, you can check the size of the table, right?
Yeah, I got.
Okay, so this will be defining the, so view, like I suppose if I change the data, like alter view, so now the new data will be the data will be replaced. So alter view, you are replacing the entire data, so you can alter view command, so redefine view. Okay, and suppose specific column you want to take it, so you can use the explode. Suppose you want to show the name with each value of the workplace. So for the one name has 3 workplace. Okay, so in my data, so like one name has Michael, and I have 2 workplace. So I want to make it separate data, right? Like this. Okay, like, so this thing I can do with the explode. Okay, so convert rows values to the column, like this. So I will use this lateral view. Okay, I will use the explode function. That way I can do. This table is employee internal. Okay, so first you create table. So like this, we can get the data. Okay. So next thing is, so I will be going a little fast forward because these are the things like we already know about the case when condition. So you can just run SQL queries. Okay. So select star from table, select particular column you want to take it, right? You can take it some regex expression way you can do. So you have to enable this property, portrait identifier. So you can find all the values like which is like, okay, so you can do. Okay, so you don't need to write all the values like array indexes, you don't need to give. So you can give simply this, so it will take it all indexes. Okay, so sometimes like now you can use this. Okay, select distinct, you can distinct, and you can check case condition, case when condition. So this is like gender is female, then you want to add MS or Mrs. or Mr., right? So this way you can do SQL. Okay. So this is all the simple queries, right? Okay, so you can create like a common table expression, right? You can define with T1 as, and then you can select the data from this T1. Okay, so you created one more additional table you created as a T1 alias from the existing table, and then you are doing the you are getting the data from this alias table. Okay, CT. So this is a common table expression. So we can run both the queries together, so we can get the data. Okay, so like this, and the limit like only 2 records. So Hive is supporting the limit, right? So we can get it. In operator is there, like we want to get particular 2 values. Okay, so we can use this, or we can use multiple values also, like gender is this female or male, or age is 27 or 27 plus 3 30. So this kind of way we can do in operator. Okay, or subquery means in operator you can write another query, so you can execute this query first and then get the result, and then you will be running the outer query. So this way we can do. Okay, subquery exists, right? So where exist operator we can use. So if this query is result, like it will check for this one, then it will get the values from the inner query. Okay, so join we can do. So for joining, right? Okay, this is another table is created for joining. So one table is employee underscore HR. Okay, and here I have to change the location. Data. Okay, so this table I'm creating. Loading the data. No file is found. Employee HR. What is the problem? Employee underscore HR dot txt. You understand what is the problem here? Can anyone tell? What is the issue? Because file is there on the same location, right? The file name is same, everything is same, right? But my command is not working, right? This is employee HR. Okay, if I see the PWD, okay, but my command is not writing the data. It's saying file not
Using
found.
the local
Yes.
file in path.
Yeah, because I'm trying to find in Hadoop location, but my
Yeah.
file is in the local. Okay, so I
Yes.
have to use local. Okay. So this kind of things you should always check, right? Okay. Okay. So local. Okay. So here is join, right? Like 2 tables I'm taking here, like one is an employee table and one is employee HR table. So I'm doing a simple equi join, right? So join with a similar column value. Okay. So here is no primary key concept, but column name and the data should match. Okay, then the data will come. Okay, so I'm doing the join. So it will be running a map to this job. There is a lot to present. I think how much we can do in that less time. Or is 20% cover only. Okay, so this is the inner join, some unequal join. You want to check the name is not matching. Okay, so this is coming the matching rows, right? In these two. Okay, so I want to get SSN and I want to get like the name. Okay, so if I want to check name is not matching the name. Okay, so that is unequal join. Some complex expression you can write, conditional join you can write, case conditions kind of one. Okay, you can write like the where clause you can keep it. Inner join, this is the inner join, but some where clause. So you will filter whatever data is coming, you will filter it with the name is particular this will. Okay, so then it will do filter limit, it will limit your data. Suppose you want to get the data from the more than one table, so 3 table join. So first table you will do employee to employee HR and employee HR to employee ID, and joining condition is same. So here is the EMP has name, employee HR is name, and employee ID is having employee.name and employee ID.name. Okay, so this way you are doing the 3 tables join and you will get the data. Okay, so these 3 tables should present, then only you can do the join. Okay, so self join is, then the join is a table itself. So sometimes like you want to calculate the salaries, right? Employee salaries greater than the manager salaries. So that kind of scenarios you want to do, you can use the self join. So self join is very like sometimes the situation where the single table you want to compare the rows of one row to other rows of the same condition, right? So you can go for the self join. So self join means you create two aliases for the same table and then you will be comparing the rows. So here I want to get the employee name is matching, okay, who are having, okay. So generally we have an employee ID and manager ID, and I want to check like who, how many employees are reporting to the different managers. So I want to get that count. Or if I want to do some salaries things, I want to check, right? Employee salary is greater than his manager salary. So this kind of things I can do with the self join. Implicit join, okay. So and different additional conditions, okay. So left join, right outer join, okay. Some streaming also we can do, okay. So stream table like we can do. And left join is left side all data and right side matching data, and non-matching data will come null. Okay, so we have two tables. So this is coming the data. Okay. So left outer join will bring the left side all data. So whatever data is in the left side table, that will bring all, and right side matching and non-matching for null. So that we can do the left outer join. Right outer join is the reverse of the left. So here is in this right side table, this value is null, no matching record. So it is coming null. But the other one, the total 4 are there, right, in the left side. So all matching 4 with the matching with the 3, and the 1 is non-matching, that is coming null. So when I do right outer join, so right side all and the left side matching and non-matching null. Full outer join is no matter matching or non-matching, all the data will come from both the one. Cross join is a multiply of the number of record. If one table has 3 and one table 4, so total 12 records will come. Okay, so that way with the cross join is there. Okay, and so these are the unequal join, or this one we can do. One is a map side join is there. So when the small table fit into the memory, so we can use the map side join. So employee table I'm fit into the memory, right? I just, but here is a like this employee, this table could be any other table also we can get it, okay. But here we are same table we are doing, here we are doing map join with the as a cross join, okay. But generally if I want to do some other department table, I can keep it as a map join, and employee table I can use it as a the table, okay. So I can make it join between the small table and the large table, I can use the map join, map side join, okay. Left semi join and left anti join. So two joins are there. Left semi is like left table, whatever values are there, that is present in the right side table. Okay, then that is called left semi. It is same like a exist operator. So either use a exist or use left semi. So when you use left semi join, it will give you the employee IDs, employee names matching on the right side. Okay, but left semi will be giving a left side data only. If you run this left semi and left anti. So left anti will be giving the employee name which are not matching in the right. So it is equivalent to the not exist. So two operators are there. One is a exist and one is the not exist. So exist one is the left semi and not exist in the left anti. Okay, so when we run left semi, So matching one from left to right, which are the matching one. But it will give the left side data only. And left outer join is giving the data from the left and right both table, depending on the matching and non-matching data. So these are all 4 are matching. If I apply left NT on this, what will happen? Okay, the left NT is left NT yeah, I think NT will be supporting or not. So checking with left join is null. So only whatever is present in the left but not present in the right. So left side present but not present in the right is null. So whatever null is coming in the right side corresponding left value, it means those are not present in the right side. So only this name. Okay, because we seen that one left join, we found it, the Shelly is getting the null value, right? This null is coming, right? So there is no right side data null. Okay, so this is the left anti we can implement. Okay. Okay, take a 10-minute break and then I will start this import export is there and some other like Sardes is there, UDF and Sardes. Okay, Sardes and UDF. Okay. Okay, are you guys able to hear me?
Yes.
Okay, so the one next thing is okay, windowing function or the group aggregation functions. Okay. So we have like when we do the select count star, so we can simply do the count star, okay, or count a specific column I want to do. So count one or number I can give or name I can give. So I can find so count star like basically give the null values also, right? But if you are giving a specific column, so null value will be excluded. Okay. In the any specific row is there null values. Okay, but count star will be giving the whole table, right? All the tables, the number of rows count. Okay. So aggregation, you can do the group by. So you can define the group by like gender. So that column should be the part of your select. So that's the main criteria, right? For any group by column. So you want to find the gender wise the count star from the table. Okay. So you can do the gender and then count star. So you will get for each gender, right? You will get the count star value. Okay. So can run query. So hive is always running the map reduce job. That's the reason it's slower, right? Because it's faster for the large amount of data. So here is a female 2, male 2. So this is a count is coming based on the group by column. Okay. So you can do more on the like multiple aggregate functions also you can apply, right? Same group by column, you can do average or count or you can do, okay. So you can do case when conditions also. So it's like more modifications you can do, like some you want to do for the case conditions, you want to keep it. Like if the male then the age, okay, as the 0. So whatever age is there, you want to take that age, otherwise you will be taking 0 if uh, the the gender is not matching, right? So that way you are doing, okay. So you are doing the case conditions and the aggregate functions, okay. And coalesce is basically when you have some values are null and you want to give some default value. So then you want to replace the value with null with 0, right? So you can give that value, okay. So you can use coalesce or you can use if condition way you can give. So if condition you are defining, if the gender is female, then you take the gender age, otherwise you can have the value 0. Okay, so that way you can do. Okay, max, min, count. Okay, so these like aggregate functions we can use. Okay, and max, min, average. Okay, so these we can simply do. Okay, some other features are there. Grouping set and grouping list is there. Like you want to create a set of values, okay, unique values, so sets is there, you can create. So it is equal to the like simply you are doing here like grouping you are doing and you are doing count, but here is a grouping set you are creating, right? So you can go through the ebook there, you can find more in the this select queries, okay, grouping set, okay, grouping list, and this is the queries are there. Union all, right? Union all will be bringing all the record whether it's a duplicate or not, but union only bring the non-duplicate. Okay, so you can bring only non-duplicate. So union and union all, this is the difference between the union all. Okay, grouping ID. So having clause we use when we have to do some condition on the aggregate function. So suppose I want to find the unique number of unique record. So I can find group by column on a particular columns, set of columns we can give also, and we can check count star 1. If count star greater than 1, so we can find the duplicate record. We can find or unique record, we can use count star 1. So we can give in the aggregate. So what is the difference between the where and having? So having is basically applied on the aggregate function. Aggregate function, we want to apply some condition, we use the having. Or if we have the non-aggregate functions column, if we have, right, so then we can use the where clause. So we can use the where clause. Okay, so if you don't having, so we can also use the like a subquery we can use. Okay, so the result will be given to the outer query. Okay. Windowing function. So windowing function is we have different row number. Okay, row number and rank, dense rank. These are the windowing functions. Generally, the third highest, second highest on a particular column wise. I want to get on the other column. So I can use the partition by on a one department ID column, and order by I can keep it on the other column. So like I want to get the salaries on the department wise, third IS, second IS only. So I can use the windowing function. And aggregate function also we can use windowing aggregate function. So we can apply the sum, average things we can apply on the our result. Okay, so we can use. So we have to do like order by salary, descending order we have to do if we want to get the third IS, second IS, that we can do. Okay. Okay, so first value, last value, this also lead, lag, these are all the windowing functions. So this we can get the values result, we can take it. Okay, max, min. Okay. So next thing is Surdays, right? Like how to use Surdays, the different file format data. So when we have the data of different file formats, so far we have seen the mostly data is a text format data, right? My data is a text, so it's stored as text file, stored as text file, and this text file data is a any delimited character like comma or pipe or any delimited character data is there. But suppose my data is JSON file data, XML data, okay, or CSV file is in the double quote data, right? Suppose my data is like this double quote data. So how can we write this kind of data? Or I have some regular expression regex data. Okay, like I have a log files data, log files. So how can we get this data, right? Like this files, how to load into. So normal way we cannot do. We have to use Survey class. For JSON, there is a JSON Survey class is there. For XML, XML Survey is there. For OpenCSV Survey is there. And regex is the regex Survey is there. Okay, so regex Survey is there. And when I want to create a different file format data, right? Parquet file, Avro file. Okay, so I will tell about what is the Parquet, Avro, and ORC. So Parquet and ORC are the columnar file format, and Avro is a row-oriented file format. Okay, so Parquet ORC is faster to read. So why we are going for these file format, right? We have already the JSON and XML, CSV data we can read, because this data is not compressed data. So these are the human readable data. This is not compressed data, and the taking a more size on the Hadoop file system. So if I want to compress it, like suppose I say one CSV file data is 3 times lesser in the ORC. Okay. So ORC is highly compressed. Okay. So if I say 3 times ORC and lesser, 3 times lesser. Okay. In ORC, and Parquet is a 2 times lesser. Okay. So in Parquet. Okay, so both are columnar file format, compressed format data, but Parquet is using snappy format. Okay, so snappy compression codec is there, snappy. So there are the different compression codecs are there, like snappy is there, Lazaro is there, GZIP is there. So these are the different compression techniques are there. So this, what is the advantage of using this Parquet? So Avro is a row oriented, it is lesser like compressed, but it has one benefit of schema evaluation support. So schema evaluation support is whenever your columns are keep changing, right? Like you are doing multiple times alters, right? You are changing your schema of your table, or your different types of data is coming. So we will use Avro. So Avro is allowing to change schema frequently. Okay, so how it is allowing, basically whenever you add a column or remove a column, add or remove column, it will not impact existing data. It will simply make it data null. So if data, suppose you have added a new column, so data will automatically become null for the existing data. Okay, for that particular column name. Okay, if you are adding a new column data, right? Or if you are removing the column, so it will remove from the existing data also. So it will not impact on the existing data. Okay, so that is a use of the schema evaluation support. So when your schema is frequently changing, we go for Avro, and Avro is a row oriented. It's a row by row data insertion, row by row data insertion. It's same like SQL DB, same as SQL DB. SQL DBs are the row oriented file format. SQL DBs. Okay. And column oriented file format are the ORC and Parquet, but ORC Parquet are the more compressed than the Avro. Okay, and for faster read. Okay, and Avro is faster write. Avro is faster way to write data into table. Okay, but generally in Hive is mostly supported ORC because ORC is a good fit for Hive table. Okay, and when we talk about the Spark, the default format. So ORC is kind of default file format. ORC is the default file format for Hive table. Okay, and Parquet is for Spark is a default format. So Spark the Parquet is good fit for Spark. Okay, and it's a default format. Okay, so this file format we should remember. Other file formats, okay, RC file is also there, but that is like ORC is the optimized row column. That is like more than the RC. So generally we use either RC, Avro, or Parquet. Okay, so when I'm using this Saturday, so what I need to do, right? So for the JSON Saturday, right, or XML CSV Saturday. So for JSON, we need some JSON Saturday class jar file we need to download and add jar in the Hive shell. So we have to do in the Hive shell, we have to do add jar, and JSON Saturday class, JSON Saturday jar is we have to set the path. And then we create a table using the JSON Saturday. Okay, so let's see that how to create these Saturdays. Okay. So when I'm going to create a table, okay, suppose my data is this is my data. Okay, this is a JSON data. So I'm creating a table, create external table name, and I'm keeping it 2 columns. One more column will come, number, and it is an integer type column. Okay, so there is a JSON Saturday class is there. So this JSON Saturday class is present in a one JSON Saturday jar. Okay, so this jar you can download it. JSON Saturday. So if you see this blog here, so here is a JSON dependency jar is there. This one, JSON Saturday dependency jar. So add jar command, you will add the jar in your Hive shell. Okay. So first thing we have to do that. Okay. So once we set it, so I have kept it this jar in my jar folder. Hive JSON Saturday jar. I will so basically in this that class is there. So this class is like which is parsing the JSON data. So this classes are all there in this JSON Saturday. Okay. So this is not by default is available. Okay. So we have to register that jar. So I will use add jar. My location of the jar. The next thing I have to create a table. I have to create a table with the JSON Saturday. So I'm creating a table. So this is some external location I'm giving. Okay, so external table, I'm creating this table like I create, and I just give some external location, my JSON data. Okay. This directory will be automatically created on the Hadoop file system. Okay. So my table is created. Now, next thing is load the data. Load data is same. Okay, that is the same command. Load data local in path. So my location is okay. So this is a test.json. I already created file. So this test.json file, I will load the data from here. So test.json and into table name. My table is a test. Okay, now I do select star from test. So I'm getting the data of 2 rows. So 1 column, and this is the 1 column. Okay, so this is the way to load the data into the JSON. Okay, JSON data to load into the Hive table. Okay, suppose I have some logs data. Okay, just I'm taking example of I have a log file. On this log file, I have columns are there like host, identity, username, okay, time, date and time, request, status, site. So this is a log file format. So how many columns are there? I will create a table with the regex array. So regex array is a class which is provided by the Hive. So this, we don't need a jar for this separately. This jar is already present in the lib folder. And here I will be defining the input regex. So what is my regex I'm providing, like what it is accepting, right? So my first field, all these are string type. So all it is accepting, right? All the data, all the values. So there is no validation is there, right? And the date is there. Okay, so there is a, I have a format like hyphen is there, right? So hyphen is there. So like this is a one time hyphen is there, right? Question mark hyphen and then value, then hyphen, then value. Okay, so we have this. I will create a table. I will create a Hive table, and I have the data, this access log. If you see this data, so this data I got it from the internet. Okay, so this is the IP is there, and then the user and identity field is hyphen, then date time is there, then the request is there, and size is there, and then status is there, like 200 status or 400 status, right? 401 is a status, and then after size of your request. Okay, and this is the request URL is there in this one. So these are the 7 fields are there. First, second, third is empty, fourth, fifth, sixth, and 7th. Okay, and I want to read this data into table. So same command, load data local in path command I will use. So I will use this load data local in path command, and I will change here my file is access underscore log. Access underscore log and remove the JSON. And into table, my table name is access underscore log 2. So access underscore log 2. So data is loaded, and now I'm creating select star from access log 2. So if your survey is correct, it will properly parse your file and write the data. If it is not correct, it will insert the null. So if you see here, all 8 rows are coming. This is all 8 rows data is coming. If you want to print the header, there is a command is there, hive CLI print header. So how to display header in Hive table? So there is a one set command is there. You have to do this one, set hive. So once you run this, okay. Okay, it is set, right? Okay, it is not giving error. Now I do select star. So I will get the header. So I'm getting, this is my host, this is my identity, second one is, but formatted way is not coming, but you're getting the column headers. Okay. So this is the regex survey, and some other surveys like Avro, Parquet, and ORC. So these surveys, you cannot write the data directly. First, you have to create a table. You have to create a table of that particular type of survey, like stored as Parquet, stored as ORC, and stored as Avro, and create a some source table, create a some source and load the data into source. And from source, then you write into the your this Avro, Parquet, and ORC, then your data will come in that particular file format. Okay. So in this scenario, okay, I have, this is my source table. Okay. So I'm just creating. Okay. So some table I'm creating. And I will prepare the data for this one. ID is 1. And ID name is, okay, ID name. Okay, this data, I will write it. It.txt. Okay, so first I create these file format data. Okay, so I ready my data. So first I just load the data into this source table. The source table is simply, I will do the same way, load data, local in path. I will give the location. In path. Table, my source one, select star from my source one. My source table is populated. Now I will create my Avro file format. So store like this Avro I created. Same like Parquet I can create. Now I want to load the data. That into test underscore Avro. So the data will come in the format of that, whatever type of format I define. So you cannot read the data manually on the disk, but you can see in the table, the same data will be there. Like either you query the Parquet or any other format. So when you select star from test underscore Avro, so you will get the data, right? So, but underlying data, if you see show create table underscore Avro. Okay. see, look at this. Slash. Okay, so this is a schema is attached with the data. So initial part you see that is a schema. So that is a schema is there. So this is the initial part is a schema and the schema is attached. Same like in the Parquet also having schema. So here you can see at least some part of the data you can see like test2, right? Something test, right? But in the Parquet you can't read at all. Okay. So this is the different file format. So this we can use regex survey, right? And like same like XML survey we can use, OpenCSV survey we can use, Parquet, and these are the surveys we can use. One is a fixed width file also there, like it's a regex only. But the thing is here, how many number of columns are there, characters are there, you are defining there is no delimited character. So you are saying input regex equal to, you are saying first 5 is for first column. Okay, so this is not for this table, but it is like data should be in the, there is no fixed delimited character. There is no delimited character, but based on the column length, your data is fixed. Okay, so in that column value, right, that number of characters column length, the data will be fetched. Okay, so that is called the fixed width. Okay, so these are the fixed width file, and other types of surveys also there. Like we can integrate Hive with HBase. So there is a external table we can create in Hive, which is mapped to the HBase storage handler. This is also HBase survey. So HBase storage handler is defining the properties, survey properties, where we are doing the mapping of the HBase table with Hive. So you are writing the data into Hive table and it will be writing into the HBase. So this is called HBase Hive integration. So you have your HBase table is linked with the Hive table. Same like Mongo, you are defining Mongo storage survey. So Mongo storage handler is there. For Cassandra storage handler is there. If you want to write the data from Kafka, the Kafka storage handler is there. But for all these types of surveys, you have to define mapping properties, because the format of the data in those particular database is different, right? So HBase is having the column family, and Mongo is having the like ID, and then there is the documents are there, like fields are called documents. So we are giving the column mapping. So mapping is defined, and the URL where your Mongo is running, the URL. Okay, so because Mongo is an external component, like external tool. Okay, so that is the reason we need URL. But HBase is a part of Hadoop ecosystem component, so it will be no need of any URL is needed. So it will be easily integrated. And here is we need some additional jar, right? If we are using external component like Mongo, Cassandra, so we have to use this survey class in this particular jar. So if we are not using this jar, so we can't use this storage handler. Okay, so this is the different storage handlers are there. And Apache Hive is providing the masking also, right? Suppose you have the different masking techniques are there, SHA-1, SHA-2, MD5, right? So you want to convert some masking, right? Some masking characters we have seen, like we can get a star or some dollar symbol. So we can do the masking. Okay, so mask function is there. Okay, we can have mask first n character. So like first 4 characters I want to do masking. So this way we can do, and we can do the select query. So for any particular table, I can use this algorithms. So this algorithm is available, right? We don't need to, like, it will be directly called. So this is MD5, one is a SHA-1 and which is a SHA-2. So it is doing encryption of the data. So there is a different encryption mechanism, AES decrypt or encrypt function is there. Okay, so we can do this security things we can apply, okay, in our Hive tables. Okay, so this one has regex array, okay, JSON array we covered. Okay. And joins, okay, some special joins also there. Okay, so there is a one is a sort merge bucket join, map join is there. So map join is a special join which is used for the small, like a table fit into memory. You can use the map side join. So map join you can start. If you want to run the Hive job parallelly, so there is a execution.parallel property. These are the performance optimizations are there. So these are the performance optimizations, right? So when you are using, okay, some optimization on the storage optimizations are doing. So these are the some max property you are defining your input number of files or input bytes, okay? So you got defined map join is a converter join property true. Bucket map join you want to use, so you have to make it this auto convert property join true and bucket map join property true. So these special joins you can use by setting these properties. So just in the Hive shell, you set these properties and then you use that particular join you can use. Okay, by default, these joins are not enabled by default. So you have to enable this converter property join true is needed for the map join, for the bucket map join, for SMB join. Okay. And skew join is like we have the data is skewed, like some data which is more number of time repeated data, so that will make your join very slow. So how can we optimize the skew? So we have to enable this optimize skew join true. So it will automatically find that the particular value which is repeated more number of time, it will exclude from the join, and later on it will add in your result. Okay, so then first it will do without using that key, that value, right, which is more repeated number of time, and we don't need to use in our join because the same result will come. So but that is making your join slower. So we can use some vectorize is there. So vectorization is basically one property is there, vectorize execution enabled true. So vectorize is like a bulk data, you can fetch it, that you can do the vectorization. So you can see some performance optimization. So in my document, you can see I have, okay. Okay, partitioning, bucketing, joins, left outer, right outer, full outer. Okay. And these are the all converter properties. You can go more detail in these. This is very good here given right about the map side join. What is the advantage of map join? Map side join. What are the parameters of the map side join? Limitation of the map side join. Okay, so some other. Okay, so bucket map join is there. Okay, so bucket map join is like bucketing they are using. Okay, then joining process. So same bucket, they will bring the same key to the same bucket. So then it will be become faster. Okay, skew join. Okay, skew join in the Hive. So these two properties we have to use. We can see the performance of the query by analyze function is there, like some analyze operator. So we have some operators are there, like analyze operator, explain operators, right? Like this is like in SQL we have similar way in the SQL Hive also we can use. So we can like see the logical plan and the physical plan, query plan, we can see and analyze. Okay, so that thing we can see. Sort merge bucket join. So SMB join is doing sorting first and then merging and then bucketing. So this is the combination of SMB. Okay, sorting, merging, and bucketing. So how it works? So sorting, merging, bucketing. So this is the explain operator, right? So that one will be giving you the complete staging plan it is showing. Okay, sorting, merging, bucketing. So comparison of internal external table. And if you want to configure any other SQL database as a Metastore DB, so you can change in the configuration file. So these are the properties: connection URL, username, password. So you can add your properties here. So your metastore DB will be created. Okay, so it will create a your metastore DB in that particular MySQL DB. So your metastore DB will be in the MySQL, so that you can do. Okay, so SQL queries, this is like Java program, how to write a Java code to a JDBC connection. So driver, you are defining Hive driver. Your class.for name, you are giving driver connection, you are making it the URL, username, and password. And then you can do the statement and execute query and get the result. And result set, right? You can iterate the result and get the data from the Hive table. So that way you can get the output. Group by queries. Okay. So same program, like whatever you can do here, the command line, you can write it the SQL query here, right? You can write select count star from group by query. So only difference is like here you are getting through the programmatic way, you are getting the data. Okay. And that is a command line. So sometimes you want to do some get the data programmatic way, and you want to pass it the data to the some other visualization tool or like some reporting, right? So you can easily do. Okay. Order by, okay, so there is a one order by, sort by, group by. So these are the 4 clauses there. Okay, so what is the difference? Group by, order by, sort by, and clustered by in Hive. Okay. Okay, group by, order. Okay, order by is a global sort. Okay, when you do order by, so order by is a global sort, right? It can have multiple reducers. Okay, when you do the sort by is a reducer label sort. So reduce by, sort by is faster than the order by. So order by, suppose you have a 3 output files. Okay, so all 3 output files sorting will be done globally. So that is order by. But when you use sort by, so sort by, you are saying sort by name. So you are doing the output file by sorting you're doing. So that sorting is faster. Okay. So order by, sort by. Group by, you will be doing the group by column. Okay. And one is distributed by and clustered by. So both are similar. Like clustered by we use in the bucketing, and distributed by we are dividing the data into the multiple cluster, right? I want to distribute, so I can use clustered by. And distributed by you use in the clustered by use in the bucketing, right? You are creating a multiple output file, so you define the clustered by key. So clustered by key you can use. Okay, so these are the 4 clause, right? Generally we use while retrieving the data, fetching data. So order by, group, sort by, group by, clustered by, and distributed by, and high performance optimizations. So partitioning is a one, right? Vectorization, cost-based optimization, Tej engine, right? The Tej is like execution engines. There is a MapReduce execution engine, Tej engine. So if you are using MapReduce execution engine, it's slower, right? Because it's generating the MapReduce. But Tej engine is faster than the MapReduce engine. And another one is a Spark engine. So Spark is much faster than the but when we are using the Spark to write data into Hive table, we can go for the Spark execution. So we can change this execution engine type. So there is a property for changing the engine type. We can change. Okay. So file format, different types of file formats are there, which are more compressed. The ORC reduces the size up to 75%. Okay. So ORC is the optimized version of the RC file format. Parquet is there, Avro is there. So these are the different file format. Partitioning is there, bucketing is there, vectorization is there, cost-based optimizations we can do. So we have to enable the CVO and indexing, right, to get the data faster based on the indexing column. So we can write the indexing. We can create indexes on the column. Okay. So these are the and differences between the Hive and HBase. So Hive is for OLAP and HBase is the OLTP, and Hive is like we can say like data warehousing tool, and HBase is the online transaction processing tool. And HBase is using the column family, the group of column together in a single column family. Okay, so that's the advantage there. In the HBase is a NoSQL database. Okay, and Hive is a SQL oriented database, SQL based. Okay, so there are the some types of processing things: OLTP, OLTP, schemas, latency. So latency is HBase is more, so low latency is there, and Hive is having the high latency because it's a map reduce conversion. Okay, so database model like relational database DBMS type, and HBase is a NoSQL, which is using the CAP theorem. SQL support. Okay, so HBase is not giving a SQL support, but there is the one Phoenix tool is there, so you can access HBase table like a SQL query. Okay, but there is a, but by default the HBase is not a SQL. Okay, partitioning is there, right, in the Hive. Okay, but in HBase is the the data is shared across the machines on the cluster. Okay, so these are the some replications is there, like both are having the replications. So and Hive and the Pig and HBase, Pig and Hive. So these are the Hive, both are analytics tool, but Pig is the lines of code. If I talk about the Hive is less line of code as compared to Pig, and Pig is most the update kind of scenarios, like you want to iterate data and same time you want to update the data as well. Okay, but Hive is just mostly the SQL select queries, right? You want to pinpoint the data in your table and you want to get the records. Okay, for that purpose the Hive is used, and Pig is basically using its own ETL. Okay, it's a ETL based tool, and the Hive is a SQL query based tool. Okay, so language use, the Pig is using Pig Latin, and Hive is using SQL queries. Okay, mainly used for the like data analytics. Okay, and this is for the update and those kind of, and operate ETL, Avro. Okay, so one more thing is there, UDF. Okay, so that one topic also I cover. So one, how to create a UDF. So I should have one project. So I open it. IntelliJ. So I'm loading the project. So simple, like I have to create a Maven Java project, and that Maven Java project, I need a dependency of the Hive, right? This UDF dependencies like Hive jar we need. Okay. So I will go to the POM. So I'm using Hive execution jar. Okay. So Hadoop client I'm using, and Hive client I'm using. So this jar is, and some other additional jar common IO. So I'm using these jars for my UDF. So simply what I've done here, I have created a one class UDF, okay, and this extending the UDF, and it is taking one input value and return as a output value is a string. So here, what I'm simply written a logic in Java, I'm taking a first character at 0, and then I'm just converting to the uppercase, and remaining characters I'm adding as a substring. So substring, when I'm giving 1 means it is taking till the length of the string, right? So this will be returning me the final string, and I'm converting the text type because the result return type in the, like here the text, right? Okay, so this text type I'm returning as a string data. Okay, so right, serializable type we needed, right? Serializable. So in the MapReduce we see in the serializable for the string data is text. Okay, so that is the reason we are using text. So we are getting input as a text and we are returning text. So whenever you are getting input text, right, you are converting to string into the string type, and then you are doing the manipulation. And again, once your result is formed, then you are converting back to the text. Okay. So I created this class and I'm creating a jar for this. So there is a, okay, it is initializing. So I have created a Maven. I have created a clean install, right? I'm using the lifecycle method of the Maven clean install. So I will create a jar. Okay. And this jar will have the package, this particular package, and the class is there. Okay. So any number of class you can create. So not only you can create a separate UDF. So one package you can create one class. So every UDF is pointing to the particular class, right, which has the logic. Okay. So this evaluate function is the function which is coming from the UDF, and we are overriding in our own class. Okay. Okay, so first thing is we have to create a jar of this project, and then we have to add the jar in our terminal in the Hive shell, and then we will write a UDF temporary function, and that function we will use in our query. So target the jar will be created. Okay, already jar is there. Okay, I'll show with this jar. Okay, so this jar I will copy it. I will keep it in some folder where I can do the add jar. So go home. This is the jar. So first I giving the username. Okay, so here I jar is added. Now I will create a function. Any name you can give as, and you have to give the fully qualified class name. So the class is this package. Or this is the class. So once this temporary function is created, now I can apply upper one name column from employee. So first letter is making it capital. Okay, let's see it is or if I'm not, just give the other. We are getting capital, right? So I can make it as name, right? So I can see the first letter of the word is coming capital. Okay, so same way you can create a find occurrence, just same class, one more class you create. It's very simple, just create a class. Okay, put this class here. Okay, make it the name, find string occurrence. Okay, so this class is created. And now you want to take it two parameter, text str1. Okay, so what the logic you change here? So I will write integer count equal to 0. And I will do, first I will split, right? String array. I will say str dot split. But this str is not a string, right? So that's the reason it's giving error. So you convert to string. Now it will not give the error. So, but this is, I need to create array type. Okay, then it will take. Now you will iterate for strs of array, you will iterate the values. Now you will check if s dot equals, and what is the value is str1. So str1 dot toString, because it's again it's a text, and then you are incrementing your counter. Okay, so this counter you have to return. Say this counter dot string dot value of, and pass the integer. Okay, so now you have return value. Okay, so what I need to do, I create jar again. It says new jar is created. So you do again register. Okay, and create a temporary function. The temporary function name I'm giving find occurrence, and the class name is changed. Occurrence. This jar is creating the classes or not, we verify by extracting the jar. The class is there, find string occurrence class. Class is created. Now the package name is changed. Custom one. Okay, this is creating. Okay, so there is some issue. Okay, so this is basically when you create a class and then you will do your select query with that temporary function. You will do the select. Okay. Okay, so it is clear this all hive related, all these things, concepts. So I will share the video and you can practice all this this commands. Okay, so already this file is there. This you can GitHub link, or otherwise I will put it all this notepad file. So all this notepad file I will put it in the drive. Okay, the same drive location I'll give it, so you can start practice. Okay, so you have any questions, doubt, you can ping me. Yeah, thanks everyone for attending session. Thank you.
Thank you very much, Arvind. Enjoy the rest of your